Welcome back, guys. Today what I'm going to be going through is what we learnt on Wednesday's lesson, which is all about trigonometric functions. If you weren't in Wednesday's lesson, please make sure you watch this before Thursday's lesson, or else you will have absolutely no idea what is going on. So in Wednesday's lesson, our focus was about learning the correct ways to label a triangle and learning about the trigonometric ratios so that you can successfully work out the missing angles and sides of triangles. So the things that we made sure we were able to do at the end of the day: firstly, you can identify the opposite, adjacent, and hypotenuse of a triangle. You can apply the correct formula to determine trigonometric ratios, and then lastly, you can find the missing sides of triangles using these ratios. So the first thing that we do is just making sure that we know how to correctly label a triangle. Now this angle here, this is what we call the beta angle. It's an unknown when it's written like this. And then when we label our triangle, we know that this, because we worked on this already, the side of the triangle that's opposite the right angle is known as the hypotenuse. That's what we remember from Pythagoras' theory. Then when we've got beta in this corner, the side of the triangle that runs along the triangle that runs along with beta is known as the adjacent. It is next to. And then when you look here, you've got the side that is opposite beta is known as the opposite. Pretty straightforward. So when we go to this next slide and we look at what is the hypotenuse, we look for that symbol that is the right angle, and we go across. We know that the hypotenuse equals 5. When we are looking at what is the opposite to A, we find A, and we go directly across from A. The opposite to A is 3. And then when we look at what is adjacent to B, what is the adjacent to B? B, it's definitely not the hypotenuse, which is 5, so it's the one that runs alongside it, 3. What is the opposite to B? We've got B here. The opposite is 4. And lastly, what is adjacent to A? It's the one that runs alongside it, 4. Alright. Now, if you weren't in class, we went through this activity where we looked at these different triangles that all had the same degree in there. So each was 37. And what we found that when we measured these distances on the page, there was something very similar about them when we put them into these fractions here. So triangle A, B, C, and D, this was all the same. When you worked out what opposite over the hypotenuse equals, it was all the same. Same with adjacent over hypotenuse. When you worked out for all the triangles, it was the same, then opposite over adjacent. These are what we call the trigonometric ratios. So there are 3 of them. So sine, cosine, and tangent. But they are just abbreviated here to sine or sin, cos, and tan. I'll refer to them as sine, cosine, and tan moving forward. So in that case, when we have an angle of 37 degrees, you should find that sine 37 approximately equals 6, cosine 37 equals approximately 8, and tan 37 equals approximately 0.75. And then when we're looking at it, when we're looking at putting that kind of principle, that sine, cosine, and tan, we have this saying here, or this phrase. It's called so, ka, tawa. So sine equals the opposite over the hypotenuse. Cosine equals the adjacent over the hypotenuse, and the tangent equals opposite over adjacent. So here it's just asking us, follow the following triangle, find the sine, cosine, and tan of beta. So we know that sine of beta equals opposite over hypotenuse. So the opposite is 15 and the hypotenuse is 7. So sine beta equals 15 over 17. Same with adjacent over hypotenuse, 8 over 17. Alright, and so on and so forth. So, if we were looking at, let me get my grid paper up. For each of the following triangles, find sine. Alright, we would be looking at going, so for this A here, we would go, alright, sine equals opposite over hypotenuse. Alright, so sine equals, alright, the opposite of beta is 3 and the hypotenuse is 5. Alright, and from that we know, that is 0.6. Alright, cosine, if we were to write that down, which I'll scroll down. So cosine of beta equals the opposite over the not the opposite. Let's get rid of that. Equals the adjacent over the hypotenuse. Alright, which we know is adjacent is 4 over 5. Alright, so that's a concept that we need to know. It's important that we know that moving forward. Okay, so when we look at finding our missing sides, this is where we're going to apply that concept here. Alright, and you need to use your calculator for this. I recommend using your calculator. Do not use your phone because it will get confusing with your phone. Alright, because it just punches out the incorrect number and it doesn't have it at the right settings. Alright, so find correct to 3 significant figures, the unknown length in the following triangle. Alright, so we've got that degree there, and we've got this is what we're trying to find out, x, but then we've also got 7 here. We know what the hypotenuse equals. So if we're looking at our work, now I'll pull this question up in the textbook. Alright, so if we're looking at, find to the significant correct figures we've got here, alright, we know that I've got this to here, I've got this degree, 61. So we don't know, it's no longer unknown, it is known to us. Alright, and if I'm looking at this, I've got the opposite and I've got the hypotenuse because it's opposite the right angle. Alright, and for me, I immediately recognize that I need to use sine. So sine 61 equals, and then the opposite, which is x, over the hypotenuse, which is 8. Now, if I go through this process, I go sine. Now, what we need to do to work out what x is, we have to get x on its own. And the way we do that, we do the opposite of dividing here. And the opposite of dividing is multiplication. So we times this side by 8. Whatever we do to one side, we have to do to the other. So this now becomes 8 times by sine 61 equals x. And if I punch that into my calculator, I know that I get 6.99 equals x. Pretty straightforward. Now what I'm going to do question D for you guys. So, I've got this triangle here. I've been given the angle. I've been given the opposite, and I'm trying to determine the hypotenuse. Alright, so I know if I've got opposite and hypotenuse, I'm going to be using sine. Alright, so sine 56 is our degree, equals 4 over x. Alright, now this is the opposite to the last one because we've got x on the bottom of the fraction. So the first thing we need to do is times both by x, so we can get rid of x, and we can get 4 on its own. So we times by x, and we times sine 56 by x, so it becomes x times by sine 56 equals 4. Alright, and I'm just going to leave that there so we can see it. But now I need to get x on its own again. So I've kind of shifted it. Now I'm going to move sine 56. So what I do here, it becomes x. I do the opposite of multiplying x by sine 56, which we know is dividing it by sine 56. Alright, that gets x on its own, but what I do to one side, I have to do to the other. So x then equals 4 divided by sine 56. And then if I punch that into my calculator, I get x equals 4.82 centimeters. Perfect. And that is all we went through in today's lesson. All right. Tomorrow we'll be going about finding those angles. All right. And hopefully we can get our heads around that. Thanks for watching, and make sure you like and subscribe to this video.